for being here.
Hola, buenas tardes, RouterCon. Por fin estamos aquí.
Afternoon, RouterCon. Oh, happy to be here. We really wanted to share our job and our studies with you done over the last months. The organization have introduced us to you. So what can I say? Juan Vázquez is a computer engineer currently working as an expert developer, and myself, Julian Vilas. I'm a UPC computer engineer and a master in information technology securities. And we have been known each other for the last years. We have been working in a 10 security company, and we thought, why don't you create something between us researchers? Let's wait until we live 8,000 kilometers away from the other. That's the original motivation for this talk. Juan now is living in Austin, Texas, and I'm based in Barcelona. That's the point. That's these small things. So basically speaking, we thought about what our research could be done, and SCADA was the main proposal. Why SCADA? Because previously we had been working, when we were in the consulting years, we work with SCADA related issues, and we think that SCADA is a very interesting one. There has been a lot of talking about SCADA in critical infrastructures, and we wanted to give our viewpoint. For this purpose, we have taken a big product from SCADA, and we have analyzed it for us to see if the topics made before about the general security in SCADA, SCADA protocols, how can you replicate a big product well distributed all over the world. Basically speaking, this is what I'm going to tell you during this presentation. The very first steps followed, and the successful results attaining in one of them. We have chosen the product Centum CS3000 from a Japanese company by the name of Yokogawa. I don't know if you know it, because in the industrial world everybody knows this. It's a Hollywood director competitor. It's a distributed control system aimed at controlling automatically plants, refineries, and energy companies, petrochemicals companies, and so on.
Muy grandes que vosotros en la web podéis entrar y lo tenéis desgranado incluso los clientes por sector, pero bueno.
I find very important clients and customers broken down regarding the categories in the list. This is the selected product. Why this and not another? There you go. The SCADA topic, and we are still seeing SCADA is very difficult to access to their software. These big products, if you start looking through them on the internet, there are many things about that. You can go to a website and download from a trial and to access the product. It's not like Firefox, where you had old versions and latest versions. You have everything to be downloaded and installed your documentation. So this product, we got a slightly old version. We knew that besides seeing on this deployed environments, let's start by here. When I started the investigation, the research, we accessed a latest version from SCADA. Now let's move on to basic elements of the products for you to understand the rest of the presentation. Now, basic elements of the product. This Centum product is a distributed control system, has these features. The field elements are the fundamental part, the more industrial part, which activates sensors, valves, the industrial components of the solution. On the other side, we can find the operating monitoring stations. These are the typical images where we can see many people surrounded by screens with charts where they show the status of the process. You can monitor this process and control it. You can say, okay, I want this valve to be open, I want this temperature to be increased, and so on. Is the glue? Controllers are the glue in between. These controllers make the automatization of consulting, checking, field elements, and to give it to the controllers and the operations managers. That's the good explanations probably, but in them in their project, because every product has its own nomenclature. The controller, there is the station control thing, engineering is called the GIS, and the field elements. When you see GIS, where the operator starts seeing the circuits and touch and put on the valves. This is the typical network architecture where the field elements are interconnected directly against the controllers with the FSAs. These are connected with the operations stations where the people are through a proprietary protocol network called VNet. At the same time, the operation stations are communicated through the Ethernet network. If you want to see how to apply the connection with other networks, generally speaking, it's done through the Ethernet network. So, I have explained the basic to you, and let's think about of what you have based upon what you did this research. We are humble peasants. We don't have too much money. We don't have a controller all over our places at our houses because it's super expensive. That's why there is not too much profound and deep research about this kind of SCADA elements. That's why we have this software. We have software, basic software, which is a huge number of binary documents, libraries, and documents installed on a PC, and gives us these functionalities and functions. It allows us to have GIS in our machines. And refineries, when they have the DIXs, it is the software. You can install it in a normal PC, or they can sell you a very interesting and cool apparatuses and so some specific hardware to control better the screens and so on. In this very case, the software allows us to simulate a controller and FSAs. Besides, we can perform all the operations that were previously done between the GISs and the controllers. We can do it and follow it up on it in a simulated way. As Juan said regarding the engineering station, the engineering process is to define the projects executed or executable within this machine. The controller has to be programmed itself, and what you operators are seeing on screen has to be constructed and has to match somebody happening. It can be triggered on its own. It's an engineering process as to deploying the very same elements. So here we lack the expensive things. We didn't have the nuclear plant, the valves, the FSAs, which is proprietary hardware. We didn't have UV network. Thank God this product has a simulating part that allows us to recreate it. It's important for us to take it into account for next coming results. If Dokawa wants to giving us some things, it would be nice for us to have it. Donations are always welcome.
Un poquito, lo primero que voy a comentaros que empezamos al principio leyendo un montón de horas de...
Firstly, we started reading many documentations and documents during a lot of hours. We aren't industrial engineers. We aren't coming from this world. As Juan said, the comparison between this software and the browsers, when you are in front of this software, you have installed it and you have to run it. What can I do with this software? You don't know how to continue running this software. So we soap in this documentation when you try to look over it. You you don't find too much. There aren't trainings. It's a very close world. So trainings are done by the same manufacturer upon demand. So you call them, you try to explain them that you are interested in the world and in their product, but they don't believe you. They don't buy it. So basically speaking, we found a software to start designing charts. We start you start this is not like Photoshop. It's not about just painting. The very first days before the editor with the pirates hats, with the hangout made the broth spill down, which is the print EF. So this doesn't work. There was crazy all around the place.
Bueno, y entonces, bueno, llegamos a punto de ver que no teníamos ni idea.
Discover we have no idea, so we continue to read more and more. And after much reading, we started getting the grasp of it, the basic notions that perhaps some industrial engineer got them from the very beginning. And we're going to tell you three fundamentals regarding these products and demos, which are the main concepts about the PSB, SB, and MB. We're going to give you some examples per se. For you to properly understand, these are the concepts that rule a normal project. We are going to program logical programmation. We're going to program some circuits, which are these controllers, and basically speaking, the main three concepts with which you are going to program these machines is like this. This is the main fundamentals. Basically, you have to imagine you have a human being, an operator. You have a temperature sensor, a thermometer, and you have a temperature regulator. When this operator is checking the thermometer, he is getting the PV, the process variable. The temperature is at 7 degrees Celsius. The PV is 7 degrees Celsius. Oh, this is a fucking chill code. So in his mind, the temperature at which we should be is 24 degrees Celsius. This is the SB, the set point variable. The set point variable, 24 degrees Celsius. We have to make it equal. The current one, 7 to. So let's put the manipulated variable of 17 degrees Celsius increase by turning the knob regulator, and the temperature will be increased up to 24 degrees Celsius. So if we take as very cool gigs, we kick off the operator and we put an operator in instead. The controller is going to do this in an automatic way. It is going to read the values from this field element. Thermometer is getting PS. The SB is a defined variable, and based upon it is going to send signals against the regulator to increase the temperature by 17 degrees Celsius. This is the gist. So we wanted to do this. It took us ages and a great effort. We wanted to create a hello world to perform testing, which replicates what I have just said to you, the same scenario. This is going to be reading data from an external process, field element. Is going to calculate, depending on the SB indicated and selected, and the PV is taken from this field element, and it's going to applicate an MV against the other process enter, which is of course the temperature regulator. This took us many hours to got them, especially because we needed to do a lot of documentation. If you confronted these machines in certain environments, if you are not inside this environment, try not to publish a lot, some special brochures and things like this. So what's the point of the operations station here? It's the operation station consult the operator is following certain charts and graphics. They consult and check PVs. They painted on these charts, and they can set up this to the controller. So let's see now a video about this point I'm trying to make. Here we're going to get up the system view, which is the program we are using to simulate. And here we define the projects. In this project, we can see that there are NFSEs virtually defined into operations stations, 164, and the other one. We're going to execute a virtual test, and now we are going to run this virtual controller and a the GIS 163. This usually takes a long time, but we did a spin up, and now it runs quickly. What you can see up there is the bar, the operator bar. What is the gist? And we can execute many functions from this bar. And more than I can access the alarm panel. Up here, we are scrolling down. There would be alarms sent to the operator to indicate how the system works, and those define these function blocks that Juan commented on. Here we can see the reports, and there's we're going to open the hello world. This over here is what the operator can see on the GIS, and it's related to the example we had put forward before. And let's say that's a water tank and or a water tanker. So we can see the PV value. This shows us the water level, and this is the current water level and numerical values. This is it. There you go. This is not for us to show you this example. Can you get it more or less? It's a very approximate explanation of how this works. This doesn't look familiar. This makes us remember what this guy did. From now on, that we talk about topics related with the methodology of works we have followed and the results we have acquired. Once we got this totally deployed, now let's discover the software. Let's analyze what services executes and what processes are being followed under it. Let's see the surface of the attack. Important thing, discover the real attack surface. That's the point. Let's now to run this software and analyze what is going on here. For you to understand all of this, when we install this software and you run Software Explorer, you can see the current process being executed and the connection networks open for these processes. You can see this minimum amount. Once we had spent so many hours reading documentation, and we were capable of performing this engineering process, how many processes done with this demo project. If you notice, it's been increased exponentially with many other processes, and these are the network connections. We can see many more communications, and if we want to find vulnerabilities, we need to know what the main points to be attacked. It would be a deployed GIS. That's why it's that important for us in this software. The software is more or less very splitted, and many components are recovered, and they are applied to another executables. So they change only the name. It's very important for us to be able to deploy a project, a whole project like this. So it's in those moments when you see the magnitude of the story you are confronting. Is different from attacking other different software. So there you go. It's important for you to see the vulnerabilities we had found, and the very first ones were when we performed the installation of this product. We discovered that by default a Windows sent to user was created, And when we checked the documentation, we saw that these references of the users has to be always presented in all the users. Otherwise, it wouldn't be working properly. So how when it comes down to transmitting the processes between the same Gs, you need to create this Microsoft user. You can this password is supposed to be changed, but it's not. It's not done like this. Sometimes Sanctum password is the right one. Segmentation privileges. That the documentation of this product talks about. Another very important thing is that the full CS 3000, everything is included. Excel's, libraries, configuration, files, all the database, everything is inside, and this is a share folder in such a way that they have modification and reading permissions for the group of users AB1, not authenticated users, but everyone is permitted to do so. So how can you fortify this? So you get the documentation and you said to yourself, what is it? They are recommending to you that Windows 2003, the permission by default is read-only. It has to have the total control for everyone. So it's a bit painful. It's not the only one thing. They also tell you the securities increase improvements from Windows XP Service Pack down. Have you heard properly? Yes. So no. This enable firework and change the configuration and some local policy configuration, and this is not to make it more robust. And it's not the only thing. We can. There are also snippets from the documentation. We are spacing on it. All these options should be detached. Firewalls, antivirus, automatic updates. While preparing well secure, this mainly applies to the Gs in a typical Windows PC. So you can also check the software. If you remember well, this version comes from 2007, and you can also find all binaries compilations files. So they are reusing as many files as possible. It is an architecture divided in many executables. They try to recover and reuse new old components, and for a new release they only compile the 3 or 2 which are really ones and news. So we talk about viruses, firewall disable. In a real network, you see how vulnerable you are, how you can log in with a null session. You can see the share border to change binaries, and services are set up from this folder. Some services are executed as systems, so at this very moment and point, the system will be very, very broken. So we want to check it out more properly. We want to revise in a better way, and we have to continue. So let's now talk about the vulnerabilities and design.
Que me lo pongo aquí, que no rompa nada. Vale, a nivel de diseño. Bueno, aquí básicamente...
Regarding designs, it's very important for us to know that many things said about typical SCADA protocols to pick with PDCs and standard things in the industry, and we insisted the proprietary protocols of these machines, when you had a lot of distributed communications to communicate with the FSAs, how the status is after this process is well done. We discovered that reality is not very different. That the biggest topic is there is a lack of authentication. There are protocols in a row with no authentication at all. Sometimes their codification or their encoding is binary, but sometimes other we can find ASCII protocols, so it's relatively simple. Some valid example I will give you: a protocol which synchronize the database between the different and various GIS. You may remember Hugo's this morning talk, we were very identified with the processes when there wasn't security at all among the communications between the aviation systems here, industrial systems, and security don't get along very well. So I will exemplify with this little protocol to synchronize database, equalize database in this protocol. It copies an FTP. It has some interesting things, but it's the typical FTP commands without authentication. I mean, you are connected directly to the service and you start running commands, control channel, data channel, and the data channel where data are in. That's it, period. Basically speaking, if you have clear how this protocol works, you can have an expert model as it is an auxiliary module, but it's very easy. It's cool. You can say that the G seconds you are going to go, and basically 3 actions. First, primo, these instructions allows the Gs to say whether the path the data path is, and all these machines are over here, and they tell you, okay, I can do a retrieval, and I can apply the password database from my project by default. I mean, asking you read from the system password of the iPad, because you did previously the link and they told you where the database is. They will give you a file where all the hashes M5 for the project are located, because the solution tries to segmentate the privileges, and they look for engineers and users. For the one who is reading the vaults, will not be able to reprogram them. And you can see in this directory the different users. They are not at the background. You have to crack the hashes. In reality, these vulnerabilities, I do think, are really, really cool when you have to confront a real attack environment against these machines, because you are using their very same protocols to access and obtain interesting information. You also have writing, so you can also hack the database. And you also can do a lot of silliness, but the gist, the main thing is to understand how the process works. The most correctable vulnerabilities are as follows, and the most difficult ones are the ones we have seen. I refer this the designed vulnerabilities, because general protocols don't implement measures, change all the protocols for everything to continue working the same way. You can take the product, you wrap it out, you kick it out, and you start from scratch.
Chulas para mí, pero a nivel de implementación, ¿vale? Pues también tienes cosas.
Those were the coolest ones, but on an implementation level, you have to execute things rather than just. When attacking a real FSIF, we didn't have it to touch the simulator. In a real environment, it wouldn't apply. Okay, overflows constantly appears. And all the bulls disclosure, responsible disclosure is being done with people for Rapid 7, and it takes us effort, because in our company are slightly slow, and we want to promote you and encourage you with a more political part for the manufacturer to pay you more attention. And this is easier because you can contact the text. Rapid 7 enters from Japanese and from other manufacturers, and this can solve everything. Disclosure experience is being okay according with CERT. If for being people from SCADA, they're very happy and are in a good mood, and their response is being slightly slow. We had been censored some bulls just before coming, but we'll be doing disclosure from all the materials, RCs, and all the modules will be published from this coming Monday. Basically speaking, for you to know the overflow vulnerabilities in this kind of services had been found. I put a name to the fuzzy. Fuzzy has been named this way: semi-guided down fuzzy. This is our fuzzy. How much do you like invent things? This is the story. The idea is you have some protocols which are easy to follow. Once the product is working, you take the protocols and you have a basic understanding of what's going on here. You take a WhatsApp with the real traffic, or you do a little reversing for you to know where the data is coming and follow the dispatching of packages, and you start following the package that is created with the processes. Oh, this is a bit tawdry. At sometimes we ask for the asking chains, and we change them for many Bs, very small databases we had it at the moment, and from then on we started seeing crashes. Type of vulnerabilities, for you to make an idea, is in a log server rusting with system in all the blocks. Logs taken and store all the Windows system, which is slightly bad, and overflow by an error copy, which is sometimes screwed up. This log service is in a port BP, and it's logging everything you are sending through this port. Many more things regarding the batch management process. You can see the service to move data from one to the other. It has to be used in the user data. The package is defined in lines. In the parsing of lines is a bit messy in the loop, and it bursts out the stash. So we have the equalized database service in the instruction and the command constructing the instructions from codecs and the arguments. You find the VC print, and it's kind of this way. When you start seeing it, it's like I will need at least a stack analysis of a code before proceeding. If you have a statics analysis vulnerability mention and sprintf, it would be fine. It's very basic. By having these vulnerabilities, the next issue is I would find it vulnerabilities from installation and protocol installation and designing. These vulnerabilities also can be exploited. It's an easy thing because at operating system level, Windows 2000, 2003 are the ones last, so there is an important lack regarding of protecting this operating system. At the binary level, there is a lack of compilation time protection, stack cookies, is a lack of linking time protections. When we did the exploit, doing the exploit, as you can say, Windows shelf is quite easy. The most interesting things of its exploits, and the funniest one, as you can see on screen, we are going to free and release all the details, and we are doing this process in a very responsible way. We deploy the express for the service of transfer of databases. Basically speaking, you take the control, you use the console and take the express out, and we are going to execute it in very cool scenarios with meta-platter in these environments. You tell them the host word with which you are going to run this issue, and it exploits, and we get it to run. We got it recorded on video for this meeting. Is okay. We have Centon privileges, and many of these processes run with this Centon user. We have seen in the installation that the fucking thing about the whole thing is now we are screwing up the process. The process now is live. We have a burst start. We have the session currently working. But okay, the process screwed out. That's the process. That's the bad thing about exploiting vulnerabilities within these environments. If you screwed up the process, it's not cool at all, because you can screw up something important in an industrial process, and this is not cool at all. So the nicest thing about the exploits is to continue the execution of the software you have pasted for the exploit to use it in a real test of these machines. You see that the process screwed it out when you did this. Let me do this. My gosh, it's working quicker than me. I can't stand it. It's screwed out when you are left the process, and when we have take out the payload, do an exit food process when the process is finished, and this makes screwed up this process.
Se puede evitar en este caso de una manera muy sencilla porque el proceso en realidad es multi.
This can be avoided because it's a multi-threaded process. When it turns out that the pilot, you can tell, okay, let's get the thread out, and a new thread will get connected to new connections, and everything is keeping alive. This is super cool. Once again, we have a method pattern. And let's make a PS to see what phase of the process we are, and let's move on. Now we did an exit. By changing the exit by a process, we can see the living process. Even though we leave the session, it's not falling, it's not falling. We do a connect to the service. Let's see if we can interact with the service for the service to keep it alive. It's not dead. Otherwise, exploitation in this environment makes no sense. If you exploit the machine and then it falls, it collapses. It's not like the explorer that can be reinitialized. No. This is the funniest thing and the fun thing about for the process to be continually executed. This is very easy. That's it. In reality, we got everything done. Everything's ready. We have shells. We had several mechanisms to get access to this. And what now? Now we are in. What can we do with all these big amount of machines? And, junks. If you don't know how to work, they'll give you a shell, and you said, okay, I will touch in buttons and buttons and buttons. What is moving on here? It's not cool at all. Now let's explain this to you. What can we do with a payload in certain Windows environments? I want to give you references. This guy from Cologne is an Aussie working exclusively in MetaPeter to improve something of a payload. He has done coolest things. Please follow him on Twitter and read his last tweet on it during the last 3 years. One cool thing, it gives supports to MetaPeter to support the windows where you are working with your sessions. This is cool. This allows you to do many things. If you want to enumerate window, you can do Railgun. Railguns is the MetaPeter extension to speak with the libraries where the process is loaded. This gives you a lot of job to do when you have multiple loads, multi-scale things. If you can capture all the short circuitry, the circuits, all the alarms, it's very interesting. We have done a little module which will capture the screens from a process. It takes the windows, it put them on the front, it maximizes, they put the screenshot, and this is cool. If the operator is not in front of it, the operator will see the windows dancing around and dancing around. We wanted to recreate a post-exploitation scenario, and it will be very useful for what we are going to explain later on. This will be super cool for you to get data from a real process. If you want to know a real engineering process you want to attack, it's important for you to know how to do what you can't do. Okay, let's touch down. You have to do it this way. Now another topic. With this technique you can read very interesting data. It would be very, very cool to move valves. For us to move valves, if you see a geesh when you are talking about protocols, you can do other stories. It would be, if you have a session like his, you'll be able to access real communications, and you don't have to make out what values are, what parameters are being touched by determined project, you make Trojan, a real project, you make Trojan, you are in the middle of the communication, you touch what is interesting for you. It's very simple for you to go the process which is talking with the CSS and make the whole communication Trojan. Here is very easy because our simulator, will work it the same way on the internet because we will have a UV need and real big machines. We have a simulator on a Windows environment communicating with TCP, even though there is simulations of TCP/IP. You inject it. How can you do it? How can you do this from MetaPeter? You access a process. You can hack it in many ways. You can introduce tools, and you have. How can I do a MetaPeter? The coolest way for us is to use the injection and so on. This invention from Stephen Fewer in 2007. He took a library which implemented a loaded of P, and you can load it on the process. You can change the loader, and it is cool because at forensics level it means that you don't see that these libraries are loaded on the process. It's a cool thing, very cool thing. MetaPeter is a receptive from DLL loaded in memory, and there you go. Local exploits are used this way, and there is a next stage that allows you instead of MetaPeter, you can get another reflect from DLL, and post exploitation you have a session to load it your own things. Basically speaking, this is what we did. Another interesting thing about this method, you don't modify the IIT, and at the forensics level it keeps it more difficult. So it's more difficult because it assesses the IIT, and you have introduced a new IIT with new functions, two more things for you to see. Let's see it in action right now.
El primer vídeo es el tema de capturar las ventanas. Tenemos un par de ventanas.
First video is about capturing the windows, the alarm windows between the backup panel, and we can take any other else. These windows are done by backup panel from his. Let's take another session for having a MetaPeter, and let's take the exploit. Be careful with this because we have exploited this service. Let's load Xshati and see where these windows are. Let's enumerate the windows. There are very few of them, and it's running with a different desktop. And to prevent these kind of things, in the segmentation of privileges with Centum, let's migrate to a backup panel, which is the desktop application from Centum. No much trouble from here. We enumerate the windows, and now we'll see all the windows from his desktop. These are the alarm windows. Let's see the process of each window, so we can do a PS, and let's see what the backup panels are, and let's put the whole system in background. And now we move to look for this post exploitation module, which is a generic module. This module is not still in the framework, but it will be put it is basically to do the screenshotting in Windows. We tell them to what kind of session has to be done, and evidently the Windows has to be accessible. Let's see. Once we have it, it enumerates the windows and does the screenshotting under the hood behind the scenes. And these are the screenshottings stored and kept from the windows. The windows are maximized after screenshotting, and then are back to 15 position with the metric exploits in the very end. You have the maximized screenshotting. These windows are from the alarm area. They are cool because they have parameters. This SLV has been collapsed and contains sensitive information regarding the diagrams in engineering station.
Vamos a continuar con la segunda demo. Nos van a matar, pero...
es muy rápida.
Vamos a continuar con...
Now let's move on to the second demo, where we are going to get communications Trojan.
En este segundo escenario tenemos dos GISes, ¿vale?
second scenario, we have two hisses and a simulated controller. In this very first hiss, we can find his name, and we are going to get up the controller and gonna set up a virtual 163 hiss, not to make it difficult. This has to be in this machine. The other machine in his 164 will have in the get up in his virtual process. This is getting up, and let's move forward to save time. These are alarms. And this is remarkable. We are in his 163. We can see the system status, and we can see that 164 he is not available yet. Let's move on to 164 here. So let's get it up, and I'm gonna move forward until it's get up totally. And then here is totally accelerated. In our virtual machine, it takes longer and longer. Oh my gosh, I got to sleep in between. In his house we have a very cool laptop because they have more computing accessories, and but they have in my laptop, oh buddy, I fell asleep. Now it's totally up, and we can see in the previous diagram and the 164 is like this. Now for me to I want to show you what I showed you previously. In the previous hisses are taking their own data from the same controller, and we have the very same example I showed you before. Here's 163 is now open. Let's move on to here's 164. Let's move forward a little bit. Let's leave it this way. A sec.
Esta es, digamos, la demo de la parte de lo que hemos hablado de utilizar Reflective.
This is reflective injection for make the whole project Trojan, their data. This is the demo. We have opened a window, the SV. We have clicked on it where the SV value appears, and let's now modify it. Something that people at the operation station can do. They can modify SVs, the controller processes, and he will act in consequence by modifying the field elements. In this very case, the SV is at 80, is now reduced to 50. And we'll set later on. Now I will compromise his 164 by using one exploit I'll show you previously. Let's load the library on, and let's execute the exploit. We are listing the process in the system, and let's identify the PV of the project where we want to inject the DLL. And nowadays we load the post-exploitation module as Juan commanded. We reset the path, our path from our machine where we have our library to be injected. We have to indicate the meta-predator session where we want to inject, and we find the PV of the process. We put it on, and now we execute this module, and what's going on is that DLL is going to be up. This exploited machine is going to be loaded in the indicated process. Once reach this point, we can see that two hisses are showing the same value. His 164 is a Trojan. It's now a Trojan. We're going to change the SV value, the value at which it should be this water tanker. Let's put now 25, and now we can see 25 in both. And what we're going to do now is to change this value in the Trojan his. We are going to put that its value is going to be 50. And pay attention please, because when I put in 50, we see that from 50 has moved to 100. We have Trojanized the communications. When this has changed the SB value, no matter what it has to be 100. we have moved to the next hit, and we have seen that its value was 100. We have modified the controller behavior by 100, and we could have triggered a small disaster. We have hacked its readings for you to see that you put 50, but it turns out to be 100. You can move around 50, and it's filling in.
Llegados a este punto, pues está claro, ¿no? El sistema está básicamente pwned, ¿no? A diferentes...
Once we have arrived to this point, we see the whole system collapsed. So we're talking about, okay, this is an isolated network, so it shouldn't be so this dangerous. That's a thought. But we said to ourselves, let's see if we can find some little things in between. Juan, do you want to comment something on it? No, you don't. Let's bear in mind that there's something from the past. When we checked the documentation, we identified what Hugo said with some charts and graphics where PDFs appears, access points, referencing some control connections, remote operations, earthquakes in between. So, time. We are running out of time now. So let's just try to find something. Do you want to speak about scan all the things project? We wanted to check all the repercussions in the world of this machine, because it was a fun theme. Documentation talk about remote access. Let's look for the company's gateways via web by showing the web entries. The cool thing, the nice thing, would see to scan the whole internet and to see if there are engineering products mapped onto the internet with VPNs, with web gateways. I don't want to see a super cool screen. I want to see those protocols we have broken and load it directly. As Viggo Mortensen says, with a pair of testicles. So 2 balls we need for that, as Viggo Mortensen said. The project scan all the things, big data, scan it, internet, the whole internet scan to get through interesting data, and to fortify internet, to look for vulnerabilities internet which are exploited in the wild, and let's sort them out as soon as possible. This is the story. Taximar people gave us a hand, and if you can get the tip, you'll see this on the Katasi exhibition room. Okay, let's do some ad and commercial regarding it. We'll go to them. Mar, you're a nice fellow. We got all this list of services. Oh, fucking bastard. What you want to do? We would like to scan the whole internet. We can't do this with BTP service, TCP services. I have some of them, but what do you want to do? You want my company shut down? No, we have some vulnerabilities. Let's scan as certain ports which are vulnerable, and let's see later on if we can find which of them are really vulnerable. From then on, the thing went forward, and some problems in between. There are some lawyers and legal issues. They are scanning web servers. Juan, go back to Barcelona, fucking bastard. You are nuts. You don't fit in Texas.
Y básicamente, ¿vale? Muy rápido, va. Básicamente cogimos 2 servicios,
We got 2 services because the tests to validate the vulnerability was very slow. We scanned the whole internet. We got 1,003,000 hits. So, oh my goodness, let's eliminate it. We scan towards high ports. We get false positives. We have 56,000. Let's do the proxy vulnerabilities to check how many are using and listening to these services to make the process. Since you have an easy, you can use meta-exploit framework, new functionality, which is that exploit chips are very useful, even though it's not intended to scan vulnerabilities. But the exploit chips is cooler than my scanning product. No worries, my friend. So let's do multi-threading against a whole network host to scan 56,000 machines with the chips from two vulnerabilities securely acquired, which allow us to know if everybody was talking about these protocols. And we found two bulky projects totally exposed on the internet, totally exposed engineering process. This is a big no-no. We'll put our hands up. I almost shoot it on my diapers. What do I do now? Diapers, we are gonna kill me.
Y en un principio, pues esto es lo que nos...
In the very principle, these are the results that we wanted to share with you, and we're finalizing with some remarks regarding this experience. Basically, experience, I would like to tell you that what do we get? Okay, we got software, which is a very important thing, and we were able to understand it minimally speaking and to do some deploy with the things that we can play around. We dissected the software, we found vulnerabilities at certain levels and at basic configuration of the base system level implementation. And we have also seen how this can affect the rest of the world. We can find real cases pullulating over the internet at problem level. This is it. Regarding problems, it's not commented now on here, but something we did in our leisure time. But it's something that, like I said, as a hobby, in our free time, because we wanted to do something joining together. Distance is a problem. We're working 8,000 kilometers away. We did some hangouts in the forums. It wasn't very cool. Resources was also a problem. We didn't have the hardware. We had a product that could simulate the whole thing, but having a VNet would that be fantastic. Relationships and attorneys, these are critical issues. We found this, but oh my god, be careful with the legal issues, with the scan the whole internet, because it can disclose problems. And are you going to expose it? Is something at the regional level? Be careful, watch out. There are so many few of us doing this. We're from Spain. Is it legal or not? So be careful.
Hola, Yokogawa, y tal.
Hello, Yokogawa. Seriously speaking, you need to be careful and don't think within the regulations, because these are critical infrastructures. Practice 7 helps us a lot with this. And that's it. Conclusions. Final conclusions. I would like to say we're talking about SCADA environments, critical environments. We saw what the levels of this security is. We should be worried about this because all attacks goes on the same line. We are identified on this same point. We are talking about hypercritical systems considered to be critical infrastructures, but nonetheless, the security levels are at 19 levels as the mere binaries in the compilations are reflections, just some pinches of salt. We are two bodies who in our free time, we don't have too much free time to do so. Without resources, with little time, with them, what can other people with a lot of resources, criminal organizations, do with a lot of more resources than us? So we need to raise awareness about these issues and get on working. If you like to get more information, go on Twitter. I will upload and more information need, more forums, and 3 purposes, and there will be releases of these issues on the next issues. We will release vulnerabilities details from this Monday on, because the disclosure is kind of not at one go. There are some things that cannot be released now, but from this Monday on, you will get the very first release with details, experts, and so on. And now, before Yokohama was put in a jacuzzi, they had been very nice in the disclosure process, but it's okay. Thank you very much for your attention and attendance.
Y nada, si hay preguntas o comentarios o...
Hola, aquí.
If you have any questions, please raise your hands. Over here, there's congratulations for your talk. I'm a fan. I'm your fan. There is a question not clear for me. I need some clarification. There were 2 vulnerable hosts, but you launched the spot. So for me, the conversion is incompleted. This has been a joking moment. There aren't 2 systems. There are 2 projects of engineering. This means that engineering project is not only a system. Controllers, there may be controllers, but you cannot see it on the internet. What we see is the HISIS, operations center, station, as he said them on a demo. You can have a project with different controllers, different hardware on a VN network, and here you can find one more system, more than one system. So we found 2 projects of engineering mapped, that were mapped. The complexity of every project, we cannot tell it now. So it was a joke. What we said on the stage was just a joke. We never collapsed the exploit. We thought of it, but of course, it's just what was a subtle thought. I was just kidding. We didn't really know the idea of what we found, but we didn't consummate this idea because we didn't dare to do so, to know what was behind the project we discovered on our path. We really screwed it up. Any more questions, please? Should I have... Yeah. If you can see us around here, we'll be in the corridors at the hall. Should you have any questions, you can wait for us outside. No problem for it.
Hola, buenas. Muchas enhorabuenas por vuestro trabajo. La verdad es que es muy interesante ver cómo es.
Congratulations on your jobs and studies. I have a question. You have performed very sophisticated attacks. I do think that an organization, low-cost organization in the opposition, how to modify all of this without knowing that the user temperature is being increased, but in his has as a vulnerable operating system as a basis. So my question is, if we collide his, which is a simple part, I'm not able to manage the control. The controllers, how do behave? How do they have any protocol of action? I keep living this. I keep doing this. Controllers are characterized by the fact that they control the plant. Controllers are thought of not to have human interaction just behind. So operation stations are for second control to be behind just if something crash out. They have the red button control. It's a feasible scenario where when you do an update like this, you change values at these points, which make that the operator manually see the values which are not real. I'm gonna stop the plan. Plan stop triggers expensive costs because once stop the plan is difficult and it takes some days to run the whole system, and it costs a lot of money for companies. This is brutal. am I responding to your question? I would like to add that we have to bear in mind that when we have compromised the hisses, we have compromised the hisses with X-rays, but we have also said to you there are some vulnerabilities that allow us to modify a project period, and you can do it through this way. You can access something and you can put a proper and a known user there. One fucking thing about this is again, one thing regarding working with simulated environments is it's a bulky software. They can have some prescription. I don't have a signal through the VP, so our change valves are these certain values. So I can use this safeguard program. We couldn't prove it because ours was a simulated environment running on OTCP. So we keep it like this. We are looking for we look through Amazon, we look valves on Amazon, but the FCC cannot be bought. So I will call Yokohama. So social engineer, okay, I shit on my trousers. Would it be cool to have access hardware to check some scenarios? Probably you have something at a circuitry level. I'm sorry about that. Thank you very, very much.